Hello everyone, we'll start the third video on psychrometric chart. So this is the chart which is available in this one BT Nijiguna thermodynamics data handbook. So all of you have taken, I suppose, and this psychrometric chart, if you know how to use this psychrometric chart, then only you can solve the problems also. And from this they are also asking some of the important information in the theory exam also based on this chart only. So this psychrometric chart which represents various properties of moisture, it is a graphical representation by taking dry bulb temperature values on the x-axis, this dry bulb temperature on the x-axis, and specific humidity values on the y-axis. So this is the dBT versus phi, that is this specific humidity, right? So the various lines identified on this chart are dry bulb temperatures. These are the dry bulb temperatures which will be identified on the x-axis. Specific humidity lines on the y-axis. Next, wet bulb temperature lines. Wet bulb temperatures lines, where they are in this fashion, they will be having wet bulb temperatures. Relative humidity lines. Relative humidity directly it will be in this curve lines like this. These are very important lines. Specific enthalpy lines. Specific enthalpy lines will be outside here. Here in the chart you can see there. In this chart it is not shown, but here it will be shown in the future slides. Specific volume lines. Specific volume lines are here. Specific volume lines. And dew point temperatures. So dew point temperatures are shown here. So dew point temperature, here it is wet bulb temperature, here also it is wet bulb, like this. So one by one we will see in detail in the upcoming slides. So various psychrometric charts can be individually represented like this. If I eliminate all the other parameters like WBT, specific humidity, relative humidity, specific volume lines, enthalpy lines, if I eliminate and only if I draw the dry bulb temperature, this chart looks like this. So these straight lines, vertical lines which are cutting the x-axis will represent the dry bulb temperatures. So please note down. So this 40, 50, whatever is shown here, these are dry bulb temperatures. Wet bulb temperatures will be on this curve. So this curve, whatever is shown here, they will be on this curve. It is determined when the air circulated past a wet sensor tip. This already we have discussed. So the intersection of dBT and WBT provides the status point. So wherever this point comes and cuts here, so here it is WBT. So wherever 5 will come and touch here, this is WBT again. 10 will come and cut here, this is wet bulb temperature, right? So next we will see saturation line. So this is the saturation line we are seeing here. Saturation line is a condition at which water will begins to condense out of moisture. It is also called as dew point temperature line. So on this curve only dew point temperature we can measure, that is called as saturation line. Relative humidity lines. So these are curved lines. It will be, I said already, it will be in the percentage. So here 20, 40, 60, 80, 100 means it is called as saturation line. Means more than that you cannot add any more moisture in that air. So that is the saturation line. After this what will form? Water only it has to form. So it is a ratio between actual moist content in the air compared to with the moisture required for saturation at the same temperature. RH affects the human comfort significantly. So usually whenever you are comfortable, what is the human comfortable? So at certain humidity, humans find very comfortable. Like in AC, if I put it at 17 degree or 18 degree, humans are very comfortable. So at that point, what is the humidity percentage? If you calculate, it will give you relative humidity, which will affect the comfort significantly. If you go on increasing the saturation, this humidity increases. If you go on reducing, it goes on decreasing. At certain point there will be a comfort point, that is called as human comfort, that can be found out later on. Next, enthalpy. Enthalpy is the energy content of dry air. See here, already in that first slide I have shown, here it was not there. So outside there will be one line containing some numbers. So whenever if I want to calculate enthalpy at 30 degree, then I should just draw this line, straight line, on keeping this line intersecting. Then at this 30 there will be enthalpy number is this. At this one, at this point if I calculate, it will be like this. So these are the enthalpy lines. So specific volume lines, like this curved lines will be there. So these curved lines we can see here 0.8008258850 like this. These are the specific volume lines which are present in the psychrometry chart. So dew point temperature, already I have explained. Once again I will explain. Dew point temperature are the temperatures which are available on the saturation line. So saturation line are this line. So after that there will be no saturation, because maximum amount of water is contained in that air is called as that saturation point. At that point, what is the temperature? So these are the dew point, this one, and straight lines are called as dew point lines. So various psychrometric process, very important in the exams, is asking some 3 to 4 psychrometric process to explain using the psychrometry chart only. So you need to draw a psychrometric chart and go for showing these. Any if he ask any 3, you can draw any 3, or else if he ask specifically these 3 or these 3, any one, so you need to explain as per the requirement of the examiner. So sensible heating, sensible cooling, humidification, dehumidification, adiabatic humidification, and mixing of air streams. So sensible heating means what? Heating, already you see this word. Heating means increasing the temperature. So somewhere around someone gives it is at 75 degree, we need to increase it to 100 degree. If I want to, if the initial temperature of the air is some, here it is 77.5. So here if it is point, if I heat it, the temperature is going to increase. So this is called as sensible heating. Sensible cooling means what? Cooling, suppose it is at 80 degree, I want to cool it to around 65. So point will come here. So at this point temperature is going to reduce from 80 to 65. That is called as cooling. How to cool, how to heat, you need to decide. So if you want to cool, you need to add, or you should have some cooling system. If you want to heat, you should use the coil, heater coil, and other things you need to heat. So that all things we can see in the applications. Now adiabatic humidification and dehumidification. See here, this is the humidity ratio we have. Humidity ratio, or it is called as specific humidity. So if I have a point and if I go like this, so if I go like this, what is called as humidity is increasing, that is humidification. And here if I come down like this, it is called as dehumidification. Means what? Value corresponding to this point, if these are increasing, then it is called as dehumidification. If the point is going to increase, it is called as humidification. Suppose point is at here, if I increase this point at this above, it is called as I am adding the humidity to that, so it is called humidification. If I have point here, if that point is increased to this condition now, then it is called as I have removed the humidity from that air, that is called as dehumidification. So later on you will see combination of all the process, sensible heating with dehumidification, cooling with humidification, and other things. So representation of all the processes in a single psychrometric chart. So see here, if this is the point, if I increase this, it is humidifying. If I decrease this, dehumidifying. If I take this point this side, it is cooling. If I take this point, it is called as heating. If I take this point in this fashion, it is called as, see here, if I am going like this, means temperature is increasing, humidity is also increasing. It is called heating and humidifying. If I go like this, temperature is decreasing and humidity value is also decreasing. So it is called as cooling and dehumidifying. So these are the important points. You need to draw this chart, and you need to write your answers on your own by reading the textbook and other things, or watching my video. Next, one more last one is mixing of airstream. Mixing of airstream, you can see we can mix. See here, one air is coming from this channel, another one is coming from this channel, and both are mixing here. So air one which is coming, it is having mass 1, W1 means specific humidity, and enthalpy of that air is H1. So air which is coming at this stream is M2, mass 2, W2 specific humidity is 2, H2 is enthalpy 2. When they both mix, and they will come out with the mass M3 is what? M1 plus M2. W3 is combination of W1 and W2. They settle at certain specific humidity, and it will come around W3. Similarly, H3. See here, same explanation is written here. Let two streams of air enter section 1 and 2, mix at section 3. Let M1, W1, H1 be mass of specific humidity enthalpy at section 1, M2, W2, H2 add corresponding values at section 2 and 3 respectively. So if I draw this points on the psychrometric chart, initially the point will be condition of this air is at this point, mass of air is this one, specific humidity, if I just draw the straight line, you will get the value, and if I just draw the curve like this, it is called as enthalpy. So at this point, and at point 2, specific humidity is less, and enthalpy is at this value is this much, mass is major. So when they both mix, they will attain condition 3. Specific humidity become this much, enthalpy, if I calculate in the straight line, I can calculate like this. Dry bulb temperature will be reaching out like this. So this is how the explanation of this. So if I have some small equation for energy balance, see here, based on specific volume, that is specific humidity, this up to this is the derivation, and based on the specific enthalpy, this is the derivation. From here, see here, M1, W1, mass of airstream 1 and specific humidity at 1, plus, because these two are mixing, they are equal to what? M3, W3. So here M1, W1, M2, W2 is equal to, so M3 is what? We know that mass 1 kg mass is mixing with 1 kg mass, means they will become 2 kg. So M3 is equal to M1 plus M2. Here it is written. So M1 plus M2 into W3. So this W3 is taken multiplied with both the terms and kept here, and M1 W1 and M1, here also M1 take this term this side, M2 take this term this side. This is the mathematical modification. Take the common terms M1 and M2 from this expression. So M1 by M2 is equal to this one, this expression we are having here, right? So this is how we need to calculate the ratio of masses, or if you want to calculate the enthalpy, specific humidity, you can calculate like this. So here similarly like this, for instead of specific humidity, we will calculate for enthalpy. Same thing here also. M1 H1 is equal to M2 H2 is equal to M3 H3, M3 is equal to M1 plus M2. So multiply this inside and it will come like this. Take the common terms M1 and M2 outside. M1 by M2 is equal to H3 by H2. M2 is equal to H1 minus H3. So this ratio is also equal to M1 by 2. This ratio is also equal to m1 by m2. So then I can say a is equal to b and a is equal to c. So a is equal to b is equal to c, like this, right? So this is how you need to derive. Very simple things. Only mathematical modifications are there. If you know this, this one is mixing with this one and result is this. So just mathematical modifications are further steps. So go on solving the derivation. So this is how we need to note down the some relations, some processes. So please all of you note down the important formulas from last 3 videos and keep ready. We are going to solve the problems in the next video. So thank you. So will ready for solving the problems. Thank you.